Let's do the next thing here. Why, after 6 years, I'm over GraphQL? Okay, reasonable. I just wanted to make sure this wasn't just like a mega article. Sometimes you get these articles and it's just like, I henceforth shall proclaim that any further usage of GraphQL shall be prohibited within the bounds of my kingdom set forth by principle of section 4. And you're like, dude, I can't read all of that. I can't do all of that. I just can't. I need you to bring it in a little bit. All right, why after 6 years I'm over GraphQL? By the way, so I have a lot of experience in these type of data fetchers. I never actually used GraphQL. I met with the team creating GraphQL before people knew what GraphQL was to talk about data fetching and caching and things like that. So like I used to be very deeply familiar with this entire world. But I've long since dipped out of that one. The GraphQL is an incredible piece of technology that has captured a lot of mindshare since I first started slinging it in production in 2018. You won't have to look far back on this rather inactive blog to see I previously championed this technology. After building many a React spa on top of the hodgepodge of untyped JSON REST APIs, I found GraphQL a breath of fresh air. I was truly a GraphQL hype train member. Okay. I like the intro. I'm excited about this. What changed? However, as the years have gone on and I've had the opportunity to deploy to environments where non-functional requirements like security, performance, and maintainability were more of a concern. This is, dude, that is such a, this right here is such a crazy statement to contrast with GraphQL. This is the crazy statement. My perspective has changed. In this article, I'd like to take you through why today I would not recommend GraphQL to most people and what I think are better alternatives. Dude, that's funny. Yeah, I would use GraphQL, except I wouldn't use it if you have concerns about security, performance, or maintainability. But besides for those three small molehills, really, if we're honest about it, molehills, I would say you can use GraphQL. Just like, what? All right. Throughout, I will use Ruby code. I can't read Ruby code. With the excellent GraphQL Ruby library for examples, but I believe many of these problems are ubiquitous across choice of language / GraphQL library. If you know of better solutions and mitigations, please do leave a comment. Now, let's begin. Attack surface. It was obvious from GraphQL's beginning that exposing a query language to untrusted clients increases the attack surface of an application. Absolutely. The availability of a simple while loop destroying your service is incredibly higher when you have one of these type of, like this as an availability. All I have to do, if you don't have things like well thought through, if you have a large list of data, all I have to do is request large lists of data from you, and I can effectively hold down your CPUs and I could take all your CPUs from you with just a while loop. And so there's a lot of stuff you got to think about. Nevertheless, the variety of attacks to consider was even broader than I imagined, and mitigating them is quite a burden. Here's the worst I've had to deal with over the years. Authorization. I think this is the most widely understood risk of GraphQL, so I won't go into too much depth here. TLDR, if you expose a fully self-documented querying API to all clients, you better be damn sure that every field is authorized against the current user appropriately to the context in which that field is being fetched. Initially, authorizing objects seems like enough, but this quickly becomes insufficient. For example, say we are on X API. Handle, I'm allowed to view this thing. Email, I shouldn't view this. User, blocked users. And sometimes I shouldn't even be able to see their public info because context matters. Yeah, that's fair. Is X like Twitter? I think so. I think they're pretty close. You got to go the other way. Go towards stricter schema with gRPC and similar. Yeah, I think that's probably fair. gRPC is a very interesting kind of difference on this. We DDoS ourselves with our GraphQL queries. You will DDoS yourself. It's not even DDoSing. You could just DOS it. A single person can just destroy things. One wonders how much GraphQL holds responsibility for broken access control climbing to the OWASP's top 10's #1 spot. Wow. One mitigation here is to make your API secure by default by integrating with your GraphQL library's authorization framework. Every object returned and or field resolved, your authorization system is called to confirm that the current user has access, which also can be, it's very, very interesting because it can also be, there's a lot of performance implications and complexity of programming when you have to do this at this layer. It just feels difficult. Compare this to REST world, where generally speaking, you would authorize every endpoint, a far smaller task. Yes, you're authorizing the usage of that endpoint, which is a very simple thing to get right. Authorizing every last field, that feels like a really hard, in my head, that doesn't feel tenable. Yeah. A well-defined wall is much easier to define. Build the wall. Build the wall. Way easier than trying to build the wall around little individual ones. All right. Not just the field, but the context in which it is used. Yeah. There's a lot of stuff you have to do there. Rate limiting. With GraphQL, we cannot assume that all requests are equally hard on the server. This is also very, very true. I can only do this in the shape of Falcor, which is the alternative data fetching library provided by Netflix that I help write. But the idea is really, really simple. I can get your movies, right? I love you. I can say, hey, give me your movies. Give me 0 through 10. Give me 0 through 10, right? So because it's a list of movies, really. It's a Lolamo, 0 through 10, and then the fields that I want, right? Well, okay, this seems a pretty reasonable request. I'm going to request 100 movies. Well, what prevents a malicious user from not saying 0 through 1,000? Just take request, copy as curl, and just change this little bit of data, and boom, all of a sudden I'm searching for 1 million videos on the back end. I'm just saying, you can accidentally end up requesting a lot of data, and then all of a sudden, it's not like... Welcome to Costco. Caching is not necessarily easy. A CSRF, yeah, you could use CSRF, but then someone can still... There's still ways people can edit stuff, right? It's not crazy to, make it difficult. With GraphQL, we cannot assume that all requests are equally hard on the server. There is no limit to how big a query can be, even in a completely empty schema. By the way, this was the huge security risk that I created at Netflix. It's hard for me to say that I solely created it. There was lots of really talented engineers that really designed a situation in which could ultimately be used to strangle Netflix with a simple with a 3-line bash script. And you couldn't roll back, you could only roll forward. Even in a completely empty schema, the types exposed for introspection are cyclical, so it is possible to craft a valid query that returns megabytes of JSON. Goodbye, server. That's all you need to do. I just tested this attack against a very popular GraphQL website API Explorer and got 500 responses back after 10 seconds. Oh, dang. Schema, type name, interfaces, possible types, interfaces, possible names, name. I just ate 10 seconds of someone's CPU time running this white space removed 128-byte query. 2 to the 7 query. And it doesn't even require me to be logged in. Dude, okay, again, a 3-line bash script, assuming you put done on its own line in the while true loop, you could just destroy someone's server. It doesn't even require a DDoS. It just requires you're just DOSing yourself. Curl in a loop, baby. That's it. It's funny that he mentions this because this was the exact thing that I brought up at the very beginning, which is the danger of these kind of things is that you open up anybody to query how they want. And if someone finds an attack vector to query your server in such a way that it causes the optimal usage of your CPU, they've effectively just handcuffed you. They just win. They've now just destroyed your business. And if they choose to destroy you, you're going to have to figure out how to change that. Yeah, it's a denial of wallet. They're going to make you, if you have auto magic horizontally scaling going on, they could just, boom, wallet gone. You know what I'm going to do? I'm going to hit you with that while loop. I'm going to make this request once a second. We'll DDoS it so you can't really tell whose it's coming from. It's not like a really high rate of requests, so Cloudflare's not going to have any idea, right? And then, by the way, Cloudflare will see that you're taking all this CPU time, and then Cloudflare will be like, yo, give me $120,000 right now, or you're done. I'm turning off your machines tomorrow. And they're going to hit you with that trusted safety team, which is actually just going to be the sales team that's not going to tell you anything that's going wrong, but that you just owe them a ton of money. You're not going to just get denial of service. You're going to get the good old-fashioned Cloudflare extortion. The trusted sales team. I love Cloudflare. A common mitigation for this attack is to estimate the complexity of resolving every single field in a schema and abandon queries that exceed the maximum complexity value. Nice. That's effectively what we did with Falcor. If we would parse your query, which are much simpler queries, by the way. We'd parse your query and say, are you requesting more than 3,000 objects? Oh, you are? Then no. Or whatever our limit was. I can't remember. Maybe it's 200 or, there's some amount of things. You can't request more than this amount of things. And we did that before the request got into our system, which would thus prevent the problem from happening. Let's see. Capture the actual complexity of the run query and take it out of the bucket of credits that resets at some interval. Allow some sort of query to run.
Welcome to Costco.
Given some sort of budget, and when that budget's exceeded, you don't run that query anymore. That sounds a little bit more dangerous. If I'm understanding this, what's being said here, this sounds much more dangerous in the sense that you could cause real users to not be able to get data because they're like, sorry, sorry, already been used. Alternative rate limit. Yeah, it's an alternative rate limit. Yeah, it's interesting. This calculation is a delicate affair to get right. Let me see what it is. Preventative query complexity. What the hell is this language that I'm even looking at? It looks like we're slicing and grabbing stuff out. I don't even know what it is, honestly. I don't even know what this language is. Like, I don't even know how to read this one. I don't know how to read that. Okay, if you're limited staff, else you're going to get, let's see. Oh, the limit. So we just do limit times child complexity, and child complexity is some value, so it must run up the chain. It starts at the little leaves and defines how difficult it is, and then goes up and just like keeps adding them. That must be what it is. Ruby is interesting for sure. Yeah. Okay. That makes sense, right? It's like how I imagine whatever is going on there is pretty simple, right? You have like your big query that's I'm going to just draw as a tree because I don't know why I'm drawing it as a tree. We're going to draw it as a tree, and so if each one of these are worth 10. You then, okay, this is going to be worth 20. This is worth 20. Then this thing must be worth 40. Anyways, I can read. Recovering Ruby dev. Okay, I don't know. I have no idea. I literally had no idea what anything meant. You can make an assumption about the complexity of these, but if you are wrong, you may end up rate limiting valid queries and not rate limiting invalid queries. Yep. To make matters worse, it's common for a graph that make up the schema to contain cycles. Let's say you run a blog with articles, and each article has multiple tags, and from these you can see associated articles. Nice. When estimating the complexity of tag-related tags, you might assume that an article will never have more than 5 tags. So you set the field complexity to 5, or 5 times the children complexity. The problem here is that the article-related tags can be its own child, so your estimate's inaccuracy can compound exponentially, and the formula should be n to the 5th power times 1. So given this query, nice. Look at that. Bam, 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 bam. Look at how good that is. Just related tag the hell out of them. That's actually super brilliant, by the way. Just get related tags of related tags of related tags of related tags of related tags. Nice. You can expect the complexity of 5 to the power of 5, or that big number. If an attacker is able to find an article with 10 tags, they can trigger a query with true complexity of something like that, 20x greater than estimated. A partial migration here is to prevent deeply nested queries. However, the example above demonstrates that this is not really a defense, as it's not an unusual deep query. Wow. GraphQL Ruby's default maximum depth is 13. This is just 7. Dang. Okay. Yeah. This is just This is just the same. This is just literally the exact same problem Falcor had. A partial migration here is to prevent deeply nested. Oh, we already read that. Compare this rate limiting to REST endpoint, which generally have comparable response times. In this case, all you need is a bucket rate limiter that prevents users from exceeding, say, 200 requests per minute across all endpoints. If you do have slower endpoints, say a CSV report or PDF generator, you can define a more aggressive rate limits with these. Some HTTP middleware is pretty trivial. Yeah, that makes sense. You just say, hey, you can't. I mean, I don't know what this API is actually doing. I assume it's probably, my assumption is it's some sort of in-memory caching from the same user can't hit the same endpoint more than this amount of 200 times within 60 seconds. I assume that's what it's saying. But yeah, this makes perfect sense. Okay, yeah, HTTP, yeah, there's some HTTP going on here. This technology makes me so annoyed. How can they not see? How can they not see that it's just that this is just broken, allowing a client to go nuts with silly patches on top? That's because you got to understand that the result, the ideal goal of this type of technology is, I guess, what you could say is noble in some sense. It allows the client to be able to change and move in a really quick sense because they are able to pivot however they want to pivot without having the back end needing to sync. Because if like real talk, if you had a get friends endpoint, and get friends returned some set of data in which you needed a new field added, you'd have to go figure out what team is in charge of get friends because you don't got no friends, and then you need to be able to convince them that they need to add this field. But then they're going to be like, Well, if you add this field, every single person that calls get friends is then they're going to also have this extra field. It's going to cause a huge amount of more data to be transferred, and we're not really sure if we want to do this. Then you have to have these long talks. You have to get managers involved, and there's all this crappy work sometimes, especially in larger orgs, just to get friends. You don't got no friends because you can't get them to add a field, and now you're angry, and then you lose even more friends because you got so angry you may have said some things that you perhaps say regret during a meeting, okay? That's why these things exist. And I totally get it. Get Friends 2. That actually exists. I cannot tell you how many Get Friends 2 exist at Netflix. There's a lot of APIs that are literally just like fetch video 2 because you know what? Fetch video 1 did one way and people needed something else and we have to keep these things up. So it's like, I guess here you go. Here's fetch video 2. XYZ is a deprecated. Use V2 endpoint. Yeah. Making enemies at meetings is my superpower. There you go. Yeah. Query parsing. Before a query is executed, it is first parsed. We once received a pen test report evidence that it's possible to craft an invalid query string that out of memory to the server. For example, this is actually really funny. Crafting complex to parse queries is such a brilliant idea. That's one thing we just didn't really have for Falcor because Falcor was really, really, really simple. Its query language. I'm not saying it was good, but it was really, really simple. A big part of the reason that this problem exists is because front end has a different locality of behavior entirely. This would never be a problem in HTMX. Yeah. In most live services, you could never create this problem, right? Because the person that's working on it, like in any of those live service ones, the problem always exists. You know, you're always working in the middle of both the front and the back, so you can kind of help with this. I can make it to Bozeman. Oh, you're coming to Bozeman? Let's go. This is syntactically valid query, but invalid for our schema. A spec-compliant server will parse this and start building an error response containing thousands of errors which found to consume 200x more memory than the query string itself. Because this memory amplification, it's not enough just to limit the payload size. You also have to limit valid queries that are larger than the smallest dangerous malicious query. That is pretty great. If your server exposes the concept of maximum number of errors to accrue before abandoning parsing, this can be mitigated. Okay, that's funny, but dang. If not, you'll have to roll your own solution. There is no rest equivalent to this attack of this severity. Facts on facts on facts. 200x is wild. Yes, 200x seems wild. For every you literally 200x or 2000x the size of the query string for how much memory you use. That is pretty wild. We going fishing, boys. When it comes to performance in GraphQL, people often talk about its incompatibility with HTTP caching. For me personally, this has not been an issue. For SaaS applications, data is usually highly user-specific, and serving stale data is unacceptable. Yeah, this is very, very fair. There is data that you want to have cached, and there's data that you really just could never cache. So I found myself missing response caches from cache invalidation bugs they cause. Yeah. Also, very interesting thing here, though, is that to be completely fair, a lot of times these client-side caching libraries or client-side fetching libraries will also have a client cache in which you just need to have another notion of cache invalidation. So in the Falcor world, I'm going to speak of it through the Falcor world because it's just the one I know, right? Every one of your pieces of data, right? So you'd have a type atom. This would be a piece of data, and it'd actually have an expires field on it. So expires field. And so it's like, hey, here's HTTP caching, but on a field level. So like it's also really hard. Expires, yeah, you get the idea. And so I find that a lot of times these dynamic caching libraries, you also have to like consider that. The major performance problems I did find myself dealing with were data fetching and the N+1 problem. I love the N+1 problem. It's the greatest one ever. I think the issue is pretty widely understood nowadays. TLDR, if a field resolver hits an external data source such as a DB or HTTP API, and it's nested in a list containing n items, it will do those calls n times. It's beautiful too, because it doesn't know. Unfortunately, the missile doesn't know where it is because it doesn't know where it isn't. And that's like a really classic problem right here. Just write a dedicated endpoint and set. Yep, that's why those things work better. A dedicated endpoint is just much, much simpler. You can just simply request, I'm not playing the video. Nightshade dude, I'm not playing the video. You can just request exactly what you want if you have an endpoint. You can't do that sometimes with GraphQL because it has to go through, it has to maintain all these things, and then when you get the data back, you then have to make another decision based on that, the results of that, to get the next thing, because you're letting the client drive the data fetching as opposed to the backend, which can contain that exact same logic, except it just makes one request, and it's much easier to kind of formulate the exact query that you want. Unique to GraphQL, though, is the fact that since it's a query language, this can become a problem with no backend changes when the client modifies a query. As a result, I found you end up having to defensively introduce the data loader abstraction everywhere, just in case a client ends up fetching a field in a list context in the future. This is a lot of boilerplate to write and maintain. Meanwhile, in REST, we can generally hoist n+1 queries up to the controller, which I think is a pattern much easier to wrap your head around. Blocks controller, I don't even dude, blocks controller is just less than application controller. It's just not even a thing, okay? Blogs, weak, limit 25 includes these things. Serializer, render the tags. I can't even read this. I don't even know what I'm reading. Ruby just looks crazy. Find params ID, render JSON, serialize blogs. No prefetching necessary here since n is equal to 1. Yeah, I know it's inherits from. It's just funnier to read this with all my normal stuff. Ruby is crazy, it is. Authorization and the n+1 problem. But wait, there's more n+1s. If you follow your advice earlier of integrating your library's authorization framework, you've now got a whole new category of n+1 problems to deal with. Let's continue with our XAPI example. This is actually a brilliant take right here. This is a brilliant data fetching take right here. User type goes for a GraphQL base object. You have a string, you have a birthday authorization with view PyPy. User policy, view PyPy, def, friends with, record. Oh no, I hit the DB to fetch the user's friend list. Yeah. Oh, brilliant. Brilliant. Because not only do you do that, when you come back and you realize you have more data to hit, you just keep on hitting this thing over and over again. Ah, what a great observation. Yeah. And then if you do this, yeah, it runs at n times. Oh, beautiful. This is actually trickier to deal with than our previous example because authorization code is not always run in GraphQL context. It may, for example, be run in a background job or an HTML endpoint. That means we can't just reach for the data loader naively because data loaders expect to be run with within GraphQL, in the Ruby implementation anyways. In my experience, this is the biggest source of performance issues. We would regularly find that our queries are spending more time authorizing data than anything else. Again, this probably simply doesn't exist in the REST world. You know, this is a lot of work to avoid REST. Have you actually, like real talk, the amount of just tribal knowledge you have to truly run something like this, the amount of expertise, is it really worth just not having a REST endpoint? Why is REST hated so much? Because people make bad REST endpoints, right? They go way too atomized. And so then all of a sudden you find yourself making 5,000 requests for something and they're just like, this sucks. Why would I ever use this? And it's like, yeah, maybe you don't want to atomize things. Maybe you kind of, maybe you want to make something that you can just call larger sets of data and just grab that one thing out. That's at least what I find most REST endpoints end up getting like hated on for, is that REST is like communism. No one has ever tried it for real. REST has no conference, so nobody likes it anymore. This is fair. I have mitigated this using nasty things like request level globals to memoize data access policy calls, but it's never felt great. Yeah. Coupling. In my experience, a mature GraphQL codebase, your business logic is forced into the transport layer. This happens through a number of mechanisms, some of which are already talked about. Solving data authorization leads to peppering authorization rules throughout your GraphQL types. Solving mutation, argument authorization leads to peppering authorization rules throughout your GraphQL arguments. Solving resolver data fetching n+1 leads to moving this logic into the GraphQL specific data loaders. Leveraging the lovely relay connections pattern leads to moving data fetching logic into GraphQL specific custom connection objects. I don't even know what that means, but that sounds great. The net effect of all of this is meaningfully test your application. You must extensively test at the integration layer by running GraphQL queries. I have found this makes for a painful experience. Any errors encountered are captured by the framework, leading to the fun task of reading stack traces in JSON GraphQL error responses. Since so much around authorization and data loaders happens inside the framework, debugging is often much harder as the breakpoint you want is not in application code. Now, I can understand that. That does sound very painful. This does not sound good. And of course, again, since it's a query language, you're going to be writing a lot more tests to confirm that all these argument and field level behaviors were mentioned are working correctly. This is a lot of work to avoid writing squeal. Why do people hate writing squeal? Just throw a little bit of squeal light in front of that and just call it a day, okay? Just call it a day. Dang, man. Taken in aggregate, the various mitigations to security and performance issues we've gone through add significant complexity to a code base. It's not that REST does not have its problems, though it certainly has fewer. It's just that REST solutions are generally much simpler for a backend developer to implement and understand. It's also really simple for a front-end person to understand as well. How do I get friends? Call API v1 friends. There you go. Here's this. You can also have you have Swagger and all those little auto generators of giving you your nice little endpoint and everything. It's really not hard. I'm pretty sure the Ruby on Rails programmers are at fault somehow. I mean, they always are. THH mentioned they truly are. Also, GraphQL is not for a single DB query aggregation, but for multi-store graph lookups. Yes, this is true. It is inherently more complex for that exact reason. So those are major reasons I am, for the most part, over GraphQL. I have a few more peeves, but this article kept growing further. I'll summarize them here. GraphQL discourages breaking changes and provides no tools to deal with them. This adds needless complexity for those who control all their clients, who will have to find workarounds. Reliance on HTTP response codes turns up everywhere in tooling. My favorite one of all time, I know it exists, is the guy getting a piece of paper from his friend in class, and then he opens it up, and it says success 200, error, and then gives out an error thing. That's my favorite part about GraphQL or any of these data fetching libraries, is that errors have to be transferred through a successful request. Nothing is better than the successful error. Nothing is better than the successful error. So dealing with the fact that 200 can mean everything from everything is okay through to everything is down to be quite annoying. Yes, it is. It very much so is. The successful fail is painful. Task failed successfully. Fetching all your data in one query with in the HTTP 2 plus H is often not beneficial to response time. In fact, it will worsen if your server is not parallelized versus sending separate requests to separate servers to process in parallel. Alternatives. Okay, end of rant. What would I recommend instead? To be upfront, I'm definitely early in the hype cycle here, but right now, my view is that if you control all your clients, have more than 3 clients, have a client written in a statically typed language, and are using more than one language across the servers and clients, you're probably better off using an Open API 3.0 compliant JSON REST API. If, as in my experience, the main thing your front-end devs like about GraphQL is that it's self-documenting type-safe nature. I think this will work well for you. Tooling in this area has improved a lot since GraphQL came onto the scene, and there are many options for generating a typed client code, even down to framework-specific data fetching libraries. My experience so far is pretty close to the best parts of what I use GraphQL for without the complexity of Facebook needed. Okay, I don't know anything about, I have not really used this. I haven't built a REST endpoint in some amount of time. And so, all right, that sounds pretty nice. So I saw some ones. I thought I saw a good one from Judo coming in here. Okay, maybe I didn't. My bad. Maybe I didn't. Let's see. The most horrible projects I've seen have been projects where a CRUD backend and a front end have separated through API specs. Yeah, that's basically Swagger plus client codegen. Okay. Yeah, that's what I thought it was, but I wasn't sure. We generated a Go client code using Open API spec. It's great. Okay, that's fine. Did you have some indication to a good course for a Rust language? Dude, where are you getting that question from? I feel it's fair to note at this point that the worst offenders of the successful error crowd are .NET programmers, observationally. Are they the kings of the successful error? Let's see. As with GraphQL, there's a couple implementation approaches. Implementation first tooling generates Open API specs from a typed/type hinted servers. Fast API in Python and SOA and TypeScript are good examples of this approach. This is the approach I have for most experiences with, and I think it works well. I think people, if I were to gauge what people like based on Twitter, it seems like people like TRPC or tan query. Tan queries. Specification first is the equivalent to schema first in GraphQL. Spec first tooling generates code from handwritten spec. I can't say I've ever looked at OpenAPI YAML file and I thought I would have loved to written that myself, but the recent release of type spec changes things entirely. With it, I could be quite it could come a quite elegant schema first workflow. Write a succinct human readable TypeScript schema or type spec schema, generate an Open API YAML spec from it, generate statically typed API client for your front-end language choice, generate statically typed server handlers for your back-end language and server framework, write an implementation for that handler that compiles, safe in the knowledge that it will be type safe. This approach is less mature, but I think it has a lot of promise. Okay, Tanstack is really nice. Yeah, Tanstack query, yeah. Tanstack. Okay. I mean, Tanner's a very smart engineer, so I'm not surprised if he wrote something awesome. I think any protocol that allows you to auto-generate a typed client with defined auth is basically okay. Yeah. Yeah. That's why I think gRPC is as successful as it is. And I'm sure if it didn't originally start off in the Google world and they made it a bit more web-friendly and really focused on getting it to work well with JavaScript, I think that it would have been gRPC would have been a really huge contender, and most people would be talking about gRPC. But it didn't start that way. It was very googly. It's very googly. They're like, what is this? Not Go. I don't care. What the hell is this? I'm not going to write anything for it. Persistent queries, let's see, are also a mitigation for this and many attacks. Oh, am I missing something? Let's see. To me, it seems like a powerful and simpler options are here, and I'm excited to learn their drawbacks. Persistent queries are also a mitigation for this and many attacks, but if you actually want to expose, this must be a 1, 2, 3 from the, I don't even know where those 1, those 3s were. Okay, there we go. Apache Thrift. Wasn't that an Uber? Wasn't Thrift originally an Uber library? Wasn't that just another one of these attempts to create effectively a typed RPC business? gRPC compatible also has a really web-friendly API. The supported language is a bit lacking, though. Yeah, but Facebook, I think, no, it was before Uber. Okay, it was before Uber. I know Uber used a lot of Thrift. Mustache Man, I know you're busy right now, but I need to know if Stas and I should start editing that video or if you're doing an entire reshoot. I'm going to try to do a reshoot potentially today. I'll tell you at noon, okay? Anyways, hey, I appreciate that. The name. That was a pretty good article. I liked that article. The moral of the story, GraphQL is the devil. I think the moral of the story is that you're likely never working in any sufficiently complex environment that would require such an intense solution that you're going to probably bite off more than you can chew. You're going to write much more code. You're going to have to become an expert in things you may not want to become an expert in to successfully use something in a decent way. Again.